So today we get to look at section 6.6, which is on vectors. So some of you may have discussed vectors in some of your science classes, about what a vector is, the definition of a vector, and all of that good stuff, right? So ultimately, like in geometry, you think of a vector as a directed line segment. So when it comes to vectors, vectors have two parts to them. Vectors have magnitude and direction. So when it comes to kind of like drawing out a vector, you're starting someplace, right? And you have this magnitude in this direction, so we're just gonna go like, uh-oh, stop. Oop, yep. And it's got a direction, so we always put an arrow on there, so it kind of looks like a ray. You guys remember rays? But it's a line segment actually, so that arrow is just kind of giving you that direction that it's going, so it's gonna end. So it always has like a little dot there on the end. So it's like, how do I get from that point to that point, right? And so you can have like magnitude and direction, so it's kind of like what direction and what kind of energy got used to get you there. Sound good? So some cheesy examples, because we all know I'm a cheesy kind of gal. So let's say you decide to drive north at 50 miles an hour. Why can't I get this to go away? Just give me, there, sorry. Ooh, So, oops, you drive north at 50 miles per hour. I don't like that green. I want a brighter green. So we're gonna start someplace, right? So I don't know where you want to start, in the driveway or the parking lot?
The garage.
No, I can't start in the garage. No. Alright. Yep, so you're here somewhere in the driveway. At the very end of the driveway, the end of your driveway faces north. And then you decide to drive north, right? And you drive north at 50 miles an hour, right? And then sooner or later you're going to stop. Either you gotta stop someplace, you know, get to your destination, you gotta get some gas, you gotta get some food, you gotta do something. So this is an example of a vector. So it does have a magnitude and a direction. So when I talk about that magnitude, my magnitude is kind of like, how did I get there? And I got there by speed, right? So my magnitude in this one is off of speed. So my magnitude would be 50 miles per hour, right? And then I also have a direction. And what was my direction? North, right? You can even think of direction as kind of like the motion that you got there, I guess, yeah, which would be your north. Let's say you were a hard worker. You're working so hard. You're working on the docks. And you decide, actually, you know what, we're going to go gardening, right? So it's gardening season. Yeah. Did you guys get to go out and enjoy at least a little bit of the weather yesterday? It was beautiful yesterday, right? To come to rain today, but it was gorgeous yesterday. I think I might be wrong, but I think I might even get a little sunburn, so. All right. So yesterday, because it was so beautiful out, you decided to pull a cart. So you pull a cart, a garden cart, because you're helping out, you know, planting some flowers in the garden. And you have to go up a 30-degree incline. And to pull it up that incline, it requires an effort. And it requires an effort of 100 pounds. So you're going to build some muscle while you're there. So if we wanted to draw this little vector, we'd be at the bottom of our little ramp, right? So we're going to start there. And we're going to go on an incline of 30 degrees. So we're just going to use our imagination and say, yep, that there was 30 degrees. That looks a little steep for 30 degrees, doesn't it? Let's go 30 degrees. Right. And then eventually, as I'm going up that incline, you know, you're not going to pull it forever. Eventually, you're going to stop someplace. So you put that little dot on wherever it is you're going to stop, right? You start and you stop. So on this one, if we talk about our magnitude, so our magnitude has to do like with our speed or with the energy that we have to use in order to get from A to B. And so our magnitude is going to be our 100 pounds. Yep, good job. And then our direction is going to be 30 degrees. Yep. So there's always two parts to these when it comes to vectors, right? All right.
We don't have to like solve anything.
Not yet. Not yet. We're gonna, right, our thing is we're gonna be focusing on like naming our vector because there's a very special way to name vectors, right? So we want to be able to name our vectors. And we're gonna do that. And here, let me show you how to do that.
Oh, please don't.
No, since you asked, you know, that's where we're gonna go. No, it's fine.
I take it back.
No, it's great. It's fine. No, right. So, so let's look at some vectors in the rectangular coordinate system. And the reason I put that up there is how many coordinate systems do we know right now?
2.
We know 2, right? We know our rectangular and we know our
Polar.
polar. Yep, good job. The polar coordinates. Yeah, all the little circles. Yep, exactly. I like circles. I like circles. All right. So, couple little when it comes to our vectors and this other thing called magnitude that we got to talk about. When you want to label a vector, they use a lowercase letter and it'll always be bold. So I'm going to say like vector V. That looks bold, doesn't it? Yeah. Oop. And then the other thing we always want to be able to write out is like our magnitude. So when it comes to our magnitude, it looks almost like absolute values. There's 2 of them, and then it's got V in the inside. Or 2 like little parallel lines, I guess, in a sense. Right?
It's like a double absolute value.
A double absolute value. Absolutely. I like that answer. Yep. 2 lines with a bold letter in between. That works too. All right. So when it comes to our little vectors, let's say like we're doing this in the coordinate plane, right? So if we wanted to, I'm just going to draw out like the first quadrant. Just because, you know, I don't have nothing better to do right now. Maybe a good color. Try orange, right? So I'm going to say that I have this vector I. Right? You know, well, we're not even going to write it out. I'm just going to draw it, right? So think of like the unit circle. There's like unit vectors in a sense. So like my unit vector I, I'm going to start at the origin and I'm going to go down the x-axis to wherever I want to go. Like right about there. Okay. And this is that unit vector I. And then from wherever I end, I then want to go, on my y-axis or going up. So I'm just going to go up some value, doesn't matter, right? Some other little vector. And then like this would be like the unit vector j. Leave yourself a little space on that because you're going to write something in front of it in a minute. So when it comes to naming like these two little vectors, maybe we want to put these little guys together. So we want to find out that direction on how we get from one to the other. So this is the unit vector, but the unit vector would only be if you were going like a distance of 1. Do you think you're always going to go 1? No, so you could go more than that. So we're going to put an A in front of, that's a really bad A. Put an A in front of our I, and we're going to put a B in front of our J. Because the distance, that A or that B, that coefficient out front or that multiplier, that it doesn't have to be the same between those two vectors, right? This could be, 3I, and this could be 5J, right? So our A and B's are a little different. So ultimately, if we wanted to figure out this little point up here, we would be trying to figure out this little vector from our origin to that point. And what's that look like? Looks like a nice little right triangle, doesn't it? Right? Yeah. So when we came up and we were talking about like our magnitude, we used a kind of couple different words, right? We used like speed, or this was technically 50 miles per hour, right? So it gave you guys like a distance, right? Same thing on this one with that magnitude of that 100 pounds. By pulling at 100 pounds is like how, almost like how fast you can be able to pull that, right? So it's giving you that direction. So when it comes to our magnitude, it's almost like the distance, right? If I can pull that cart at 100 pounds, I'm going to get to a farther distance than if I could only pull it at 20 pounds. Does that make sense? Same thing if I'm driving. If I'm driving 50 miles an hour, I'm going to get farther than if I only drove 25 miles an hour. So to figure out that little, our vector from here to here, we want to find that distance. Right? And that distance is the same thing as our magnitude. So I really want to find my little V guy, right, with my two little lines. And we know we made a little right triangle. And we also need to like try and find out what this angle is, right? Because isn't this everything that we've been doing like these last 2 chapters? When it comes to this angle, finding this angle and using some trig to be able to find all of these signs. So we want to be able to find like that little angle over there. Right? So when it comes to naming our vector, so that's our little bold V. So when we want to name our vector, we're adding these two vectors together. So you're adding on AI plus BJ, right? But we need to find our A and our B. So if we just sit there and kind of take our little triangle for a second, I'm just going to draw him, I'm just going to draw him down here. Right? We knew this was a right triangle. We knew this guy was theta. And we're just going to look at that A and that B, right? And we know that this was our magnitude. Because we have a right triangle, is there a little theorem that we know that we can use to solve 3 sides of a triangle? Pythagorean theorem, right? So Pythagorean theorem, like a squared plus b squared equals c squared, right? So for us, we would have a squared plus b squared equals our vector, or our magnitude squared. So could we solve it just for our magnitude? Could we square root both sides? Right? And if you square root something that's being squared, it's going to take the squares away. So we get a squared plus b squared, the square root. We can't do anything with that, equals our magnitude. So two things that you can do on this, like you can always just kind of, well, let me write it up here again. That a squared plus b squared equals our magnitude squared. You can either kind of like memorize this, I mean, which you guys already know, or kind of always think of it in this end, where you're taking that square root of a plus b. Right? So we know that our magnitude equals the square root of a squared plus b squared. So now we just got to figure out how to find a and b, isn't it? So if we look at our little guy over here, or even we can look at this one. If I want to think of all of your little trig identities, right? And if I wanted to solve for a, and looking at my theta, I never have room on this guy. We're just going to scroll it up for now. If I had, oh, I want a different color. Cosine of alpha, oops, what's cosine of alpha going to equal? What's cosine what over what? Yeah, and if you have a triangle, SOHCAHTOA, right? Because like, what's your x going to be on here? Is that your a, your b, or your magnitude? It'd be a, right? Because which way do you go for x? Like left and right, right? So a over, what's our hypotenuse? Yeah, the magnitude. Right? How would I get a all by itself? Yeah. So if I look at this guy, what part do I want to get rid of?
Magnitude.
The magnitude, right, which is in my denominator. So to get rid of the magnitude, I'd have to multiply by the magnitude on both sides, right? So I'd have the magnitude of cosine of alpha equals a. What happens if I take sine of alpha? What do I get? Yeah, b over the magnitude, right? Multiply both sides by the magnitude. So the magnitude of sine alpha is going to equal my b. So I'm going to scroll back up here to where all this naming of the vectors. So we just now know that, let's keep it all green, right? A equals the magnitude of cosine alpha, and B equals the magnitude of sine alpha. So these are the four little equations that we got to kind of keep in our back pocket on some of the stuff that we need to know in order to be able to name all of these. All right, you ready to put all that into action? Yeah, man, we're ready. Let's go. All right, so let's say they want us to write the vector v. So write the vector v in terms of that vector I and j. And they're going to give us a magnitude There's our little lines with our vector in there. And they got to give us a direction, right? Because what makes a vector? Magnitude and direction. So they might tell us that our magnitude equals 20. So we got our magnitude of 20, and then they're giving us a direction. They're giving us a direction of 20 degrees. So they want us to be able to write out our vector. So our vector equals AI plus BJ. Right? And you can make those bold if you want. I'm running out of ink, making everything so bold up here. So, do we know our A or our B right now? No. But do we have a little formula to help us find our A's and our B's? Yeah. What did we say A equaled? Yep. Yep. So this was our, whoops, back to the old ink. Our magnitude of V times the cosine of theta, right? So A equals, what's our magnitude? 20 times the cosine of theta. What's our theta? Oops. 120. I'm shrinking this. Why am I shrinking this? What am I doing? Yep, 120. So A equals 20 times, anybody know what the cosine of 120 is?
-0.5.
Yeah, negative 0.5 or negative half, right? So simplify that down. Our A is going to equal negative 10, right? So we figured out our A. So now we just need to find our B. Yep, and what's B? The magnitude of sine theta, yep. So B equals 20 times the sine of 120. So B is going to equal 20 times, and make sure you give me the exact value, not the estimated value, because we want to make sure we land on the moon and don't pass it. So what's the sine of 120 degrees? Yeah, square root of 3 over 2. So our B is going to be, we can simplify that a little bit. 10 square root of 3, right? So I think we now can actually name our vector, right? So our vector is going to equal A, negative 10, times that unit vector, that positive x-axis, right? Plus B, what do we get for B? 10 times the square root of 3, times that J, which was our y-axis vector. And now we're good to go. Sound good? And if we kind of, using a little bit of our noggin, right? We knew that vector I had to do with our x, right? Ooh, yeah, look at that. Felt like Return of the Jedi there for a minute. Yeah. Ooh, oh no, now I'm erasing the galaxy, right? And we knew that our J had to do like with our Y, right? So where's 120 degrees? What quadrant?
2.
2. And in the second quadrant, our x's are always negative, and our y is going to be positive, right? So it kind of helps you when it comes to, you know, in a nutshell, double check it. That should be negative and that should be positive because we're talking about 120 degrees. Does that make sense? Not too bad? All right. So your 6 problems for your homework,